In this video, we'll be looking at the differences when you're scaling length versus scaling area when making pictographs. For an example, we'll make a few pictographs comparing the population of Japan and the population of South Korea. If we're making a bar graph to represent these populations, then we are measuring length. The bar representing the population of Japan is 10 centimeters high. So we just need to find a proportional length for the bar for South Korea. Japan's population of 127 million used a bar that was 10 centimeters. So Korea's population, only 50 million, would be how many centimeters? Solving this proportion, we get about 3.94 centimeters. And so the heights of these bars are proportional to the population of these countries. The population of Japan is about 2.5 times more than South Korea. 50 times 2.5 is 125, and the population of Japan is 127. So we have a bar for Japan that is about 2.5 times higher than the bar for Korea. Here we can clearly see the population of Korea times 2.5 is the population of Japan, approximately. We have to be more careful when we are using pictographs to show areas that are proportional to quantities, like the populations in this example. So for example, if I want to make a square whose area represents the population of Japan, and I'm going to make a side of the square be 10 centimeters. A square where each side equals 10 centimeters has an area of 10 times 10, 100 square centimeters. If we use the result from our last example, when we scaled by length, and a 10 centimeter bar for Japan meant a 4 centimeter bar for South Korea, a square with each side that is 4 centimeters has an area of 4 times 4, 16 square centimeters. And what is the ratio of these areas? 100 compared to 16 is about 6.7 times bigger. But we know that the population of Japan is only about 2.5 times bigger. Our issue is that we used a proportion to find the length, but our pictograph is now representing area. So we need to redo our proportion not with length of one side, but with whole area of the square. If we go back to our square representing the population of Japan, it was 10 centimeters on each side, so an area of 100 square centimeters. So now the proportion is, if the population of Japan is 127 million, and the area to represent that is 100 square centimeters, then for Korea, whose population is only 50 million, how many square centimeters should we use? We get a result that the area should be about 39.37 square centimeters. If we know what the area of the square should be, we have a way to figure out how long one side should be. We know that if you do know the side, then that number times itself would give you the area. So if you have the area, then doing a square root will give you back what one side should be. So a side should be equal to the square root of 39.37, which is about 6.27. And here's a square where each side is about 6.27 centimeters. So the area, when we multiply 6.27 by 6.27, is about 39.37 square centimeters. We've done some rounding here with these square roots. And now we have areas where the area representing the population of Japan is about 2.5 times bigger than the area in this square representing the population of South Korea. So when we're setting up a pictograph where areas should be proportional to quantities, we know we have to set up proportions actually working with those areas, and then we can use a square root to find what the side of a square should be. And we'll see the same concern when we use circles instead of squares in the pictograph. Let's choose for Japan to use a circle that has a radius of 10 centimeters. And here's the circle with a 10 centimeter radius. We know already that it wouldn't be accurate to try to make a circle with a 4 centimeter radius, thinking all the way back to when we scaled the length in the bar graph, but just to take a look at what would happen. Here's the circle with a 4 centimeter radius. Visually, we can spot already that This circle is definitely much more than just 2.5 times bigger when it comes to area. The radius, the distance from the center of the circle to the edge, that is 2.5 times bigger for this circle compared to the other, but the area is much, much more than 2.5 times bigger. Remember this formula for calculating the area of a circle, pi times the radius squared. So let's calculate the areas of these two circles. I'll approximate and use 3.14 for pi. The radius is 10, and remember order of operations, so we'll do the exponent first and then the multiply. So the circle representing the population of Japan has an area of about 314 square centimeters. A circle with a radius of just 4 centimeters is an area of about 50.24 square centimeters. And now we can set up a ratio to compare these areas. 314 square centimeters compared to 50.24 square centimeters is about 6.25. So we've constructed circles where the area of the larger one is 6.25 times larger than the smaller. But again, we're trying to represent the population, which is only 2.5 times bigger. So just like the example with the squares, our issue was that we used a proportion to find the radius, but what we actually need to do is use a proportion with the areas. So if we choose to use a radius of 10 centimeters for this circle representing the population of Japan, it means 127 million people are represented by the area 314 square centimeters. Remember, this was our pi times the radius squared to give us the area. So, for South Korea, where the population is 50 million, we're using a proportion to figure out what area we should use. Solving this proportion, we get that the area is about 123.6 square centimeters. So if we're interested in making a circle that will have an area of about 123.6 centimeters, what kind of radius will we need for this circle? We can think about solving an equation to figure out the radius, because we know the area is found by pi times the radius squared. If we know the radius, we would square it and multiply by pi to get the area. In this case, we know the area and need to work back to find the radius, so we can undo these operations. If we take the area and divide by pi, that will give us r squared, and we know that undoing a square is a square root. So we can take our area, divide by pi, and do the square root as the opposite operation for this area formula. So 123.6 divided by 3.14 is about 39.4, and then the square root is about 6.3. And here's the circle with a radius of about 6.3 centimeters, and the area is about 2.5 times smaller than this red circle, or this circle is about 2.5 times larger than this one. And that relationship in size is based on the areas of these two circles. So constructing pictographs where we want areas to be proportional, make sure that we are working with proportions and using the areas and not other measurements like radius or length.